Welcome to this tutorial on how to improve your Carbon LDP query performance. For this exercise, we are using a database containing information about movies. We can see the structure of this database on the left. We have a container of movies that has documents of type movie and a container of persons with documents of type person. A movie document has the following properties: name of type string, date published of type date, and actors, author, and directors, which are arrays of references to objects of type person. For this example, we are using our own MovieX demo. In it, we have a view in which you can see detailed information about people. At the end of this view, we want to be able to display the filmography related to this person. Let's work on the query for this. We already have a service, so we can write our queries. This service takes care of the query execution and returns the query results to our person view in the MovieX demo. First, note that we are using some personalized utilities to get extra details on our information once the results are retrieved from the database. Also, note that we already have Carbon LDP instantiated in the Carbon LDP variable. Within this object, we have already configured the connection to our Carbon LDP instance, and we have extended the schemas so that we need to interact with the Carbon LDP platform and our data. Let's start developing our function. It will be named getMoviesByPerson, and for clarity, let's specify the Carbon LDP tool we will be using to retrieve the information. In this case, the document reader. Now, this function receives the ID of the person whose profile we are displaying, which is a string, a limit, and an offset as numerals, in case we need them further on to perform pagination, and finally, a detail level. This last one was added by us to get the details of the results of the queries, but this is not mandatory. Finally, this method returns a promise, which is an array of movies. This movie object is an interface that contains the properties mentioned earlier. Let's begin with our query. We have our Carbon LDP instance in the Documents endpoint, the getMembers function, which gets an array of documents of any given type. We can use this to search for movies. This query will go directly to the movies container and we'll have to consider the following. The documents we are trying to get are of type movie, so we'll include that in our query builder function. Also, we want all the documents we're looking for to comply with a specific schema, which we will define next. First, we want to retrieve the movies that the person in the profile has been. To make sure that the retrieved information is filtered correctly, we are performing a subquery to specify this using the values method. Since the actor's property contains references to other objects, we'll have to include the object method to filter the specific values we want to our query to match. In this case, we defined that we want to retrieve the movies with an actor's property that references the person ID sent to our method as a parameter. Besides the actor's property, we will ask for the date published property as well. This property allows us to order our results. Once we're done defining the properties we want to retrieve, we then order them by date published in a descending format. Also, we're adding the limit and offset provided in our parameters in case we need to add pagination. Our query is now ready, and once it executes, the results will be stored in the variable named raw results, which will be an array of type movie and document, where movie is an interface we've defined, and document is a type provider by Carbon that allows for added functionality in the objects retrieved by our query. Next, we are using the utility mentioned earlier by using our function getDetails with a detail level variable as a parameter. the raw results we obtain from the query, and the results type to get additional data we want to display it in our UI. We return those results, and we finish with this function. Now, in our person detail page, we are using the function we just implemented to display a person's filmography. We are building this project with React, so we have to assign the contents of the filmography to the state of the page. Let's get them. We are doing this with a variable named filmography_promise that will store the results from the getMoviesByPerson method from the movie service. We'll call it with the parameters we mentioned before. First, there is the person ID, which we can obtain from a person object, which we have in this page. Next, we determine the limit as 9 and an offset of 0. At the detail level for card properties, a component used to display results. Once we have our promise instantiated, we will wait for it and then assign it to our state. We now go to see this live. We can see that we have the person's details, and down below we have the movies the person was involved in listed. However, these movies are only the ones where the person is an actor. We know there might be movies where the person participated as an author or director. One of the limitations of the document reader is that filtering information by values can only be done over a single property. If we did that by another property, such as director, Clint Eastwood needs to appear both as an actor and a director to meet the condition. For this reason, let's use a different Carbon LDP tool to retrieve the same information. We will take our function's declaration and use the same parameters to do a new version. For this version, we are using Sparkler instead of the document reader. So we'll modify the method's name. Remember, this name is not mandatory, but we are using this to identify the different functions efficiently. For this function, we are performing a Sparkle query using Sparkler. Sparkler is shorthand for Sparkle Query Builder, and it's a tool developed by the Carbon LDP team that allows for JavaScript developers to easily build queries that comply with Sparkle's grammar. We are using an enum to declare the variables in our query. These are movie and date published. In this enum, the value on the left is the one used in the code, and the value on the right is the one used in the query. With Sparkler, we must assign the body of the query to a variable and then execute the query using that variable and a specific SDK endpoint. Let's create the query body using Carbon LDP's document endpoint and the Sparkle method. We are now defining the type of query we want to execute. In this case, we want to perform a select distinct to get all the movies without duplicates, which is why we're using our movie variable. We want to select all the information retrieved, and in the where clause, we are providing a function that Carbon will transform into a Sparkle query. We want to specify a set of clauses that our information must meet to be retrieved, so we're using an array to detail them. Our first clause is that the retrieved objects must be of type movie. So we are defining a variable movie that has a type movie. We use a resource notation to define the type because types in our database are stored as resources. Now, we want this movie to have a relation to a specific person. In our previous example, we did that via the actor property, but in this case, we can do this with any type of relation. We are declaring a new variable in the variable enum, and we are defining that the object we need to retrieve is related to a resource in our database with the person ID we are receiving as an argument through that variable. Once we have all the related movies to a person through any property, we want to check that the relation between that person and the movie is the one we are looking for. This means whether the person was an actor, a writer, or a director in the movie, we're doing this with a filter function that receives specific syntaxes. In this case, we are using a template string that allows us to do a string with multiple lines and insert variables within it to make this more readable. In here, we are specifying that the variable that is linking the movie and the person resources has one of all the multiple values. We are retrieving these values from the movie schema where we had already defined them. We are selecting the property that may link both resources, and we are using its ID since this is the information stored in our database. In this case, we are using an OR to link them since we know the relationship is valid for either of the cases we described before. Now, from the previous query we have developed, we are missing the date published property, so we are adding it below. Our query is almost done. We need to include the order by clause using descending by date published and using the offset and limit provided. Now that our query is ready to be used, we need to execute it. We're storing the results of this execution to the variable query results. To execute this query, we are using the execute function, which is available in our Sparkler query object. Our query results are stored in an object, and we need them to be an array of movies. So, we will extract the results from the object. To achieve this, we are accessing the bindings property in our result object, which is where the information is retrieved. Then, map the values we are interested in, which are the ones related to the movie variable. Now that we have an array of movies and documents, we are making these results much more detailed with the same function we used before to get the movie details. After doing this, we can return our detailed results and finish with implementing the getMoviesByPerson method using the Sparkler tool. Going back to the person detail page, we can call our new function and execute it. We can now see that we not only have movies where the person is an actor, but movies where the person had other roles as well. We can also see how the Sparkler tool converted our code into a Sparkle query. Since we are using Sparkler, this transforms into a single line string, but we can use an online query validator to analyze it in a more readable format. At first, we can see several prefixes. All these prefixes are used in our database. We don't write them in our query, but Sparkler does that for us, so we don't have issues when we do our queries. Then, we have our query translated completely to Sparkle syntaxes. With this query, we are demonstrating the third approach Carbon LDP offers to run Sparkle queries executing raw Sparkle. We go back to our service and reuse our function declaration specifying using raw Sparkle. Just as the other functions, it receives the same parameters and returns the same objects. We could be using an enum again to state the variables in our query, which are movie, date published, and relation. And we could use the movie schema once more to declare the types of properties we are using for code maintainability purposes. For this example, let's take the query we generated earlier and execute it directly. We need to specify that the person ID needs to match the argument received by our method. Since we are using template strings, we can insert any values we want with this notation and insert our person ID. To get our results, we are doing something similar to the previous example. We are storing the results in a variable named query results And in this case, we are using our Carbon LDP instance, the documents endpoint, and its execute select query method. As you can see, there are other methods we could call depending on the form of the query we want to execute. In this case, since we are doing a select query, that's what we are going to use. As a parameter, this method is receiving the query body we previously built as a string. Just as in the previous example, this method will return an object. So we're using our previous code to retrieve the related values to the movie variable. And we can call the other function to get the detailed results. Once those results are ready, we can return them. Before we continue and go to our demo to see this live, we need to add the prefixes Sparkler included for us. We'll do this using an already built function that gives us all the prefixes needed further on. We can now see we get the same results. When we check our Sparkle query, we can see this query has several lines and is keeping this as strings. If we introduce this in our query validator, we get the validated version in a more readable format, just as we did before. Now we know how to implement these three approaches for movie searches. Let's now compare their performance. We are using the console.time functionality provided by JavaScript to demonstrate the differences in run times related to these three approaches. We are assigning a timer for each function to test their performance. Finally, we call them at the same time to compare them. We go back to the live page and open our console so that we can see the time each function took to execute. In here, we see that Sparkler and RawSparkle approaches have a similar execution time. This is because they are both executing the same query. The difference is the approach you take to building the query body. On the other hand, we can recognize that the document reader approach takes longer to execute. This can be explained by the fact that the document reader keeps developers away from the complexity of Sparkle, and to achieve this, it builds a generic and more complex query to retrieve similar information to the other approaches. We can see this in a more detailed way if we inspect the request sent in the document reader approach. After putting our query through the query validator, we can see that the executed Sparkle query is a construct and has a more complex form. Overall, the Carbon LDP JavaScript SDK allows for the accessing of data in three different manners. Each one is there for a different kind of programmer, and each one has its strengths and advantages. For people who are more familiarized with JavaScript but are not at ease with Sparkle, the document reader is an excellent option. The queries built with this tool are easily refactorable and maintainable out of the box. It provides a fluent interface with methods that help you specify the information you want to retrieve. On the other hand, people with at least basic knowledge of JavaScript and Sparkle may find Sparkler the middle ground between JavaScript and Sparkle more suitable for their needs. It allows users to create complete Sparkle queries with basic knowledge of JavaScript, all while promoting an orderly way of coding. Using this tool enables the full power of Sparkle to be used while allowing for maintainable and clean code. Finally, for people who have more experience with Sparkle, executing their RawSparkle queries are a more natural solution. The SDK also provides the freedom to do this fast and simple. Thank you for watching this tutorial. If you want to learn more, follow the links below and hit subscribe to get our updates.